guys, so as I told you last week, I'm going to be posting a video of the assignment that we had for the unit circle. So I tried to print it so I could write on it, but I was having some printer issues, so I'm going to just have to use the computer screen and then write on some paper. Okay, so here's the unit circle. To refresh your memory, the the cosine is your x coordinates and the sine are your y coordinates, right? And then if you have the tangent, you have your y over x, right? Sine over cosine. So you can use the unit circle to answer these questions below, all right? So I'm going to do number 1 for you. I'm not going to do every single problem on here, but I'll do, just a few. And then you let me know if you have any questions. So if I want to do for number 1, I'm finding the sine of 7 pi over 4. So I'm going here to my unit circle, right? And I have, sorry, let me scroll up here. Here we go. 7 pi over 4 is right over here, right? So let me just come over my paper. We're going to find the sine, cosine, tangent, all the 6 trig functions of 7 pi over 4. All right, so I also have the unit circle right here next to me, so I can show you that while I'm writing. So again, 7 pi over 4 is right here. Okay, it's at negative 45 degree. Okay, it's in quadrant 4. Okay, my cosine and my sine are right here at my x and y. So for the sine, I'm going to find all 6 trig functions of 7 pi over 4. Now, that's easy to see because the sine, as I said, is your y coordinate. So the sine is negative radical 2 over 2, okay? The cosine of 7 pi over 4 is, again, I'm going to look at my unit circle. Cosine is your x, and your x is positive radical 2 over 2, right? Okay, and now my tangent of 7 pi over 4. Now remember, tangent is sine over cosine, or y over x. So 7 pi over 4. So y over x. So negative radical 2 over 2 over positive radical 2 over 2, right? It's sine over cosine. So anything over itself, right? This is a 2 here. This is equivalent to what? Negative 1, isn't it? Right? This is negative 1, right? Anything over itself is 1. So the tangent of 7 pi over 4 is negative 1. All right, and then when you have cosecant, secant, and cotangent, remember, cosecant of 7 pi over 4, that is the reciprocal of sine. So you have negative 2 over radical 2, okay, which you have to simplify. That's going to be negative 2 radical 2 over 2. This cancels, and I have negative radical 2. Okay? And then secant of 7 pi over 4 is your reciprocal of cosine. So this is just going to be same thing, but it's going to be the positive version. So that's going to be positive radical 2. It's the same exact work here, except it's not negative. Okay? And then tangent matches up with the cotangent. So the cotangent of 7 pi over 4, well, let's see. What's the reciprocal of negative 1? If I have negative 1 over 1, what's the reciprocal? 1 over negative 1, right? Same thing. So it's still negative 1, even though it's the reciprocal. Same thing, like the reciprocal of 1 is 1. Reciprocal of negative 1 is negative 1. Okay? So that's how you would do numbers 1 and 2 here. Okay? Let's talk about number 3. Find the find theta, right? Whatever this says find theta, that means find the angle. At what angle, right? Find the angle if the cosine is 1/2 and lies in quadrant 4. Okay? Let's see. Why don't I just use this one here? I'm in here in quadrant 4. My cosine is my x coordinate, right? So the question said, if your cosine is 1/2, what is the angle, right? So I'm going to go over here. I'm in quadrant 4. Where is my x 1/2? That's this right here, right? So at what angle is that? This angle right here. It doesn't specify whether, sometimes it'll say, put it in radians or degrees, but this would be at 300 degrees. So it's going to be 300 degrees or 5 pi over 3 radians. I would accept either, So at what angle is your cosine in quadrant 4 1/2? So at what angle is your x-coordinate in quadrant 4 1/2? So you would say when theta is 300 degrees or 5 pi over 3. Same thing. It's just one is degrees, one is radians. Okay? So that would be number 3. What else? This we talked about already, putting from degrees to radians. Whenever you want to do this, the easiest thing to do is just replace this, replace the pi with 180. So here, I have my calculator right here. 11 pi over 6. So here, let's look at my, let me clear this out. 11 times 180, right, divided by 6 is 330 degrees. Okay, so that's pretty straightforward. What else we got on here? All right, this is, again, pretty much the same thing, except this time, instead of giving you, you know, they're just showing you the diagram of what degrees. So what is the cosine at 90 degrees? Well, let's look at my unit circle. What is my cosine at 90 degrees? Well, when I'm here at 90 degrees, my cosine is my x. So the cosine at 90 degrees is 0. What is my sine of 90 degrees? 1. Okay? Let's see, what else we got? Let's do another one of these. What's a good one? I don't know. Why don't we do this one? What is the tangent of 225 degrees? So I'm going to go to my unit circle, and I'm going to go down here to 225 degrees. What is my tangent? Well, my tangent is y over x. So this over this is just 1, right? They're both the same thing, so anything over itself is 1. So the tangent at 225 degrees is 1. Are there any on here that were undefined? Let me see. Is there a tangent of 90 degrees on here? Let me look. No. I don't think so. Sine. I don't know. All right, so let's see. What else should I do from here? The cosecant of 90 degrees. Oh, that's a good one. Let's do number 17. The cosecant of 90 degrees. Okay? Now, the cosecant is the reciprocal of sine, right? So let's just go over here to 90 degrees. If I want to find my cosecant, why don't we first find my sine, right? Let me move this over here. All right, so if I'm looking for the cosecant of 90 degrees, okay, I want to find my sine, okay? My sine of 90 degrees is what? Well, if I'm at 90 degrees, my sine is 1, right? Because that's your y. So, what is my reciprocal? What is my cosecant? 1. So your cosecant of 90 degrees is also 1. Let's see. I feel like the rest is pretty much self-explanatory. Oh, why don't we look at one that's in radians? Let's see. 19. What is the sine of pi over 4? So, again, this is the same thing but radians. Pi over 4 is over here at 45 degrees. What is my sine? Radical 2 over 2. Okay? Hold on, let me see what else is a good one. Oh, let's talk about the negative ones. I wanted to talk about this. All right, so 21 and 22 were negative. So I wrote here, remember, clockwise is the negative direction. So for example, 330 degrees positive, right, is the same thing as negative 30 degrees clockwise, right? So what does that mean? Well, if I say where is positive 330 degrees? If you're going just the regular direction, it's going counterclockwise. So again, I'm at 30 degrees, 60 degrees, 90 degrees, 120 degrees, and so on and so forth. If I went all the way to 330 degrees, I'm over here, right? But if I measure negatively, that means I'm over here at the start, and I'm going clockwise. So 330 degrees positive is the same thing as me going negative 30 degrees. Do you guys get that? All right, so for number 21, if I want to say, what is the sine, cosine, and tangent of negative 150 degrees, okay? So negative 150 degrees, that means I'm going negative 30, negative 60, negative 90, negative 120, negative 150 degrees is the same as this right here. These are what they're called coterminal angles, okay? We didn't talk about that vocabulary word, but so this negative 150 is the same thing as right here, 7 pi over 6 or 210 degrees. So if I wanted to evaluate my sine, cosine, and tangent, I would do that through here. So my sine is -1/2. My cosine is -3/2. And my tangent, so why don't I write tangent? So the tangent of -150 degrees is, well, I would do y over x. So -1/2 over -3/2. All right, so right away I know it's going to be positive, right? Negative over negative is a positive. So that's -1/2 multiplied by the reciprocal, right? So what does that give me? Cancel, cancel, right? So what do I get? 1 over radical 3, which is, oh, sorry, did I cut it off? Radical 3, I'm sliding here my paper, over, oh my God, I need to hold my paper. Radical 3 over 3. Sorry, I did that like kind of go out of the frame here. All right, do you see why it's positive? Because you're having the negative, okay, the negative is still there. The negative times the negative makes it a positive. All right, and remember, we're rationalizing this radical times radical 3 over radical 3. Yes? Yes? So I guess, so for number 22, the cotangent of -pi/2. So positive pi/2 is up here. Another way you can look at it is positive pi/2 is up here. So negative pi/2 is also the reflection, which is right down below, right? So if I have positive 45 degrees is here, negative is the reflection right down here, right? So negative pi/2 is down here. Oh, this is a good one. This is one I want to talk about. So I wanted to find the cotangent of -pi/2. So the cotangent of -pi/2, right? Well, what is my tangent? My tangent is y over x, right? So if I wanted to find the tangent of -pi/2, I'm getting y, which is -1 over x. So -1 over 0, which means the tangent at pi/2 is undefined. I think I talked about that briefly in the presentation the other day, but I was trying to find one that had that, right? So the tangent at -pi/2 is undefined, but the cotangent, what's the cotangent? The cotangent's okay because it's the reciprocal. So the cotangent is 0 over -1, which that's okay. That means it's 0. So the tangent is undefined and the cotangent is 0. Make sense? All right, so I'm getting up there in time. I'm at 13 minutes, and it takes kind of a while to upload. So let me know if you have any questions about this, and then we will be moving on, okay? Have a great day.